Welcome, network engineers. In this explainer, we're going to dive deep into Brocade VDX. My goal is simple. By the end of this, you'll be so ready for any interview question, any real-world challenge involving this tech, you're going to feel like a pro.
So let's just jump right in, shall we? We're about to unpack the core ideas that really separate a modern fabric architecture from the kind of traditional networking that, most of us grew up with. It's a whole different ballgame.
And here's our plan of attack. We're going to start with the basics, the VDX foundations. Then we'll get our hands dirty with core configuration. From there, we'll look at how to monitor the fabric's health, what to do when things go wrong with troubleshooting, and we'll wrap it all up with management and high availability. It's all about going from the why to the how and then to the what if.
Okay, let's get into our first section. It is absolutely critical to understand what makes Brocade VDX and its VCS fabric technology such a massive leap forward from those old, clunky network designs.
You see, a switch like the VDX 6730, it's not just another box that pushes Ethernet packets around. No way. This thing was purpose-built for the modern data center. It's designed to handle your everyday server traffic and your high-performance storage traffic. We're talking FCOE, or Fiber Channel over Ethernet, all on the exact same piece of hardware. That convergence, that's the secret sauce.
And this slide just lays it all out perfectly. Over on the left, you've got the old way, ruled by spanning tree. Now it works, but it forces you to block half your links just to prevent loops. It's like building an 8-lane highway and then closing 4 of the lanes. But on the right, that's the fabric model. It uses a protocol called Trill that lights up all the links, so you get every single bit of bandwidth you paid for. And the best part? You manage that whole stack of switches like it's one single device. It's a huge simplification. So let's just really hammer home those benefits. I want you to think of a VCS fabric as turning your whole rack of switches into one giant intelligent brain. You log in one time to manage the whole thing. Need more ports? Just plug in a new switch and boom, it automatically joins the fabric. And any config change you make on one switch, it gets pushed out to all the others automatically. It is all about making things simple and making it easy to grow.
So what's the magic trick here? How is it so much faster and more efficient? Well, like the slide says, it's a technology called Trill. Unlike Spanning Tree, which is trying to find one safe path, Trill is basically doing layer 2 routing. It uses the super robust ISIS routing protocol to learn about every possible path, and then it actively uses them all. What does that mean for you? If a link fails, the network reconverges almost instantly. It's incredibly fast.
All right, so that's the theory. Now let's move on and see how this all translates into the practical, hands-on configuration commands that you are absolutely going to need to know, whether it's for an interview or just your day-to-day job.
First things first, let's cover the absolute basics. Show running config shows you what the switch is doing right now. And copy running config startup config? Well, that's how you save your work so it's still there after a reboot. You are going to use these two commands constantly.
Now, for a super common task. As you see here, we start by creating VLAN 100 and giving it a helpful name. Then we dive into the specific interface, Ethernet 1/1, and we use a few switch port commands to tell that port it's an access port and it belongs to our new VLAN. It's just a simple, logical flow that you'll do a million times.
Okay, next up, the port channel, which you'll also hear called a lag. This is your standard link aggregation. It's just a way to take a bunch of physical cables and trick the switch into seeing them as one big, fat, resilient pipe. It's essential stuff, so let's see how you actually configure it on a VDX. Here we go, a real-world example. We create the LAG, we give it a name, server lag. Now the keyword right there is dynamic. That's what tells the switch to use LACP to actively talk to whatever's on the other end and negotiate that bundle. After that, it's easy. We just assign the physical ports and then configure the new logical interface, in this case as a trunk that can carry all our VLANs. And now, this is a total game changer, VLAG. It takes that whole lag concept and literally stretches it across 2 separate physical switches. Your server has no idea. It just thinks it's plugged into one super resilient switch when it's actually connected to 2. This is how you get true device-level redundancy. If one of those entire switches dies, traffic just keeps on flowing through the other one. It's amazing. So how do you actually set one of these up? It's actually a pretty straightforward 4-step process. You make sure you create the exact same lag config on both of your switches. You assign the physical ports. You tell one to be primary and the other secondary, and then you just let LACP handle the rest. Follow these steps and you've built an incredibly resilient, dual-active link to your most important servers.
Okay, so you've built your awesome fabric. You've configured all your links, but how do you keep an eye on it? How do you make sure that everything is healthy and running the way you expect? Let's look at the must-know monitoring commands. These 3 commands right here. They're like your window into the fabric's soul. Show ISL shows you the health of the inter-switch links that stitch the whole fabric together. Show Fabric Membership tells you exactly which switches have joined your logical chassis. And Show Fabric ISL Statistics gives you all the juicy traffic data for those links. Honestly, these are your first stops for any health check.
All right, now for the fun part, the what-if scenarios. Because let's be real, things don't always go according to plan. So let's walk through how to hunt down some of the most common performance problems you're likely to see out in the wild.
Ah, yes. The classic ticket from the app team. The network is slow. We've all been there. When you get that call, you can't just start randomly pinging things. You need a system, a methodical way to find the root cause fast and figure out if it's really the network or something else.
And this right here, this is your playbook. This 5-step process will save you so much time. You start broad, check the overall fabric health. Then you zoom in, check interface stats for any nasty errors or drops. You look for oversubscribed links. You double-check your quality of service config. And finally, you pull out the big gun, the traceroute fabric command, to find the exact path and any potential hotspots.
Packet drops. They're the ghost in the machine, aren't they? They can be so tricky to solve because they happen and then they're gone. But don't you worry, the VDX fabric gives you some seriously cool tools to hunt them down.
Now, the thing that makes this command, traceroute fabric, so powerful is its incredible precision. Remember how the fabric uses multiple active paths? Well, that means 2 different servers might be taking 2 completely different routes. This command lets you trace the exact path that a specific device's traffic is taking. It's like putting a GPS tracker on your packets. It is a troubleshooting superpower.
Okay, let's bring it all home. In this final section, we're going to cover some of the day-to-day management stuff and, more importantly, how you actually design a VDX fabric from the ground up for maximum bulletproof uptime and resiliency.
Now, I don't want you to just see this as a list of features. This is a blueprint for a rock-solid data center network. We use VLAGs to make our servers resilient. We build multiple ISLs to make our fabric resilient. We turn on data center bridging, or DCB, to create a lossless environment for our storage traffic so it never ever gets dropped. And for the ultimate protection, we can deploy 2 totally separate fabrics, an A and a B. That's the gold standard for any mission-critical environment. We have covered a ton of ground, from the deep-down theory to the practical, hands-on commands. But listen, the absolute best way to make all this stuff stick is to get your hands dirty. Find a lab, spin up a virtual environment, build a fabric, configure some VLAGs, and run those troubleshooting commands. Go on, start building, and really put these powerful ideas into practice. You've got this. You're ready.